Okay, so welcome to this video. This video we are going to look at finding the volume of a frustum, and the question says the following diagram shows the frustum of a cone. They've given us the radii for each, the upper circle and the lower circle, and the height of the frustum has been given to be 7 centimeters, and the pi has been given to be 3.142. How do we find the volume of the frustum? Now, to find the volume of a frustum, I have to take you back to a cone. You know what a cone is, right? So we are going to do some form of extension to this already drawn cone. We are going to have something like this already drawn, right? Okay. We are going to have something like that to something which is already drawn, that you understand what we are talking about here. So we have a cone like this, right? And that cone has been cut again, and this is a height we are talking about there, the one, the 7 centimeters which has been given, and from there to there, that's the 5 centimeters that you are seeing, and from there to there, that is the 1.5 that you are seeing. Now, how do we find the volume of the frustum? We can only find the volume of this part here if we know the volume of the entire cone. Then we subtract the volume of a smaller cone. So we need to know the volume of a bigger cone minus volume of a smaller cone. That will give us the volume of a frustum. These are the only things that you need. Now, how do we know the volume of a bigger cone? Now, extend this height up to the end there. Call that height to be x. If that height is x, which is the height of a smaller cone, right? But the smaller cone is starting from there. That's a smaller cone. And the bigger cone all the way from there. So the bigger cone starts all the way from there to here. That is a bigger cone. Okay, so so now let's go and define the volume and find the x here, the height x there. Let's find it. Let me call it x in terms of red, x, right? So let's find that x. So we can only find x using what to call the ratio of similar figures. Remember, we have a smaller cone and a bigger cone, right? They are all similar. They are not the same, but they are similar. What do we mean by that? That means the ratio of their sides can be expressed in simple ratios. So the ratio of their radii, which is for the, radii for the smaller one, we divide by radii for the bigger one, must be equal to the ratio of the heights. Now the height for the smaller one is x, and the height for the bigger one, remember the height for the bigger one is taking up x and 7. So that would be 7 plus x. Okay, then we cross multiply. Now, what is r in this case? R is 1.5. The capital R is 5, equal to x, 7 plus x. Then we cross multiply there. This is the first step that we need to do. I don't know that there's follow the steps. This is 6 marks. So following the steps will actually earn you almost all the marks, which is better. So we now, here you use a calculator. So remember we are multiplying 1.5, 7 plus x equal to 5 times x, we get 5x, right? So 1.5 we multiply by 7, we are getting 10.5 plus 1.5x is equal to 5x. Then 10.5 equals, this one goes to that side, becomes 5x minus 1.5x. So 10.5 equal to 3.5 x. Then we divide both sides by 3.5 and this side by 3.5, right? So we have our x equal to, so we are saying 10.5 divided by 3.5. It's giving me 3. Now x is 3 centimeters. Now the same x, remember I said, is the height for the smaller one. So we are saying, therefore, the height for the smaller cone is 3 centimeters. And the height for the bigger cone is 7 plus, remember we said 7 plus x, so plus 3, which will give us 10 centimeters. Now that we have this, we can now find the difference in volume, right? Let's go and find the volume for the bigger cone. Volume of bigger cone, I'll put it here. Now volume of a cone is given by 1/3 by r squared what? H. Now we are not going to use small letter h, we're going to use capital letter what? H and capital letter R. So r squared then h, like that. Okay. Now we now plug in 1/3. We are multiplying by pi has been given to be 3.142 multiplied by the radius for the bigger one is 1.5, so it is 5. So just put 5 centimeters squared multiplied by the height is 10 centimeters. So volume for the bigger cone is equal to, let's now plug in, that is 5 squared is 25 times 10 times 3.142 then by 3. It's giving me 261.8 cubic centimeters. So this is the volume for the bigger cone. Step 2 is that we find the volume for the smaller cone. Same formula, just different values. Pi, instead of using capital letter R, we are going to use small letter r and small letter h. 1/3 multiplied by pi is 3.142 multiplied by r is 1.5. When we square it, the height is 3, the one that we found here. So volume for the smaller cone equals, so 1.5 squared, you get that times 3, you get that times 3.142 by 3. It's giving me 7.07 after you round it off, right? Cubic centimeters. Now remember, there's a formula that I gave you. I said volume of a bigger cone minus volume of a smaller cone should give us the volume of a fluster, and we're going to use the same one. So volume of a fluster equal to bigger cone volume is 261.8 minus 7.07. So 261.8 minus 7.07, and it's giving me volume of a fluster to be 254.7 cubic centimeters. That's how you find the volume of a fluster in a right way. All these steps, they earn you marks. Don't jump to a single formula.